This is my CA2 assignment from first BTech and second semester. The subject name is chemistry and my topic is principle and applications of a gas chromatography. I am from A section. Chromatography. Normally the chromatography is an separating the components of a mixture. Components in a mixture is known as chromatography. The chromatography is derived from Greek word chroma means color. The chroma means color and graphene means to write. Finally, the chromatography is color to write. The chromatography, as usual, the chromatography means it is a process of separating components of a mixture. It is known as chromatography. There are different types of chromatography. There are three types of chromatography: gas chromatography, liquid chromatography, and superficial chromatography. The gas chromatography. Now we have to discuss about the gas chromatography. Gas chromatography consists of a gas solid chromatography and a gas liquid chromatography. In both times, gas is used as mobile phase and liquid is used as stationary phase. Principle of gas chromatography. The principle of separation in GLC means gas liquid chromatography is a partition. The gas, as usual, the gas is used in mobile phase and liquid is used in stationary phase. The liquid which is coated onto a solid support is used as stationary phase. The mixture of the compounds to be separated is converted into vapor and mixed with gases with mobile phases. The component which is more soluble in stationary phase travels slower and evaluated later. The component which is less soluble, they travel faster and evaluated out faster. These are the differences between the component which is more soluble and less soluble. More soluble means travel slower and evaluated later in stationary phase. The component which is less soluble means travel faster and evaluated out in the stationary phase. The number of two components have the same partition of coefficient of the fixed combination of stationary phase and mobile and other conditions. Hence, the components are separated according to the partition of the coefficient. In case the component is a GLC, the separation the partition coefficient is separated. If the component is a gas liquid component, the partition will be separated. There are some applications of gas chromatography. The mainly gas chromatography is used in the qualitative analysis in the lab, and the second point, the gas chromatography is used in the purity of the compound, to checking the purity of the compound. And the third point, the percentage of the impurities may also be calculated from the gas chromatography. Means the percentage of the impurities, the how much percentage of the, if in case the example the any compound will take the how much percentage of the, if in case we can take any metal, we can find out the how much percentage of the copper in that, how much percent of the brass, how much percent of the aluminium, like that. By gas chromatography, we can find the percentage of the impurities may also be calculated from the gas chromatography. Multi-component analysis or determination of the mixture of drugs is also by means used in the gas chromatography. The isolation, identification of the drugs or metabolites in the urine, plasma, serum, etc. can be carried out. It means isolation and identification of the drugs or metabolites. You have to identify the drug, which type of drug it is, which type of component it is. We have to identification by the gas chromatography. In some of the paramedical applications, the gas chromatography is used. So these are the applications, these are the principal applications and some important points about gas chromatography. So this is about the gas chromatography principle and applications. Thank you.